Hi guys, welcome back to week 11 for functional anatomy. So it's our final week of content for this subject today, which is very exciting. I'm sure you're all looking forward to getting to the end of the semester. Now, this week we're looking at somatotyping, and it's unfortunate that we couldn't be face-to-face for this week because it is quite a practical tutorial. So I'm going to talk you through it like we would be face-to-face, but unfortunately because of the resources that are required to perform the practical activities that we do in class aren't really readily available around your homes, it's not gonna work out that way. So if you haven't already, please make sure you go and watch the lecture first. So Lee also covers the topic of somatotyping in the lecture, so there's going to be quite a bit of a crossover today, so between the theory that Lee spoke about to the practical that I'm going to talk us through today, and we're going to find out how we actually measure our somatotypes. So those of you who are here now should already have a solid understanding of what the somatotype is and the different classifications, being endomorph, mesomorph, and ectomorph. Something that's really important is that understanding that these three classifications exist on a scale. So for endomorphy, for example, that's a measure of leanness or of fatness. So you'll receive, when we do the calculations, you get a number from 0 to 8. And that number sort of works on this sliding scale of leanness to fatness as you get to the higher end. So we'll figure out from some dummy data a number for each of these three variables. So you get a number for endomorphy, a number for mesomorphy, which is the measurement of how muscular you are. So going from 0 being quite slender to 8 being quite muscular. And then the same thing for ectomorphy, which is really looking at the ratio between our weight and height, how sort of tall and light we are versus short and heavier towards that 0 number there. So when you get all of these three numbers, you get a number for endomorph, a number for mesomorph, and a number for ectomorph, you end up with your somatotype. And you can read your somatotype on a chart, and you would have seen these charts all through the lecture with all these numbers here. So they're all sets of three numbers. So the first number always is representing that endomorph number. The second number always represents the mesomorph number. And then the third number always represents the ectomorph. So whenever you read this chart here, that's what you're looking at. And what you'll notice is that those people who are really high in endomorphy, they place on the chart on the bottom left-hand corner. So you can see the numbers in the bottom left-hand corner, right where that word endomorphy is written. They have very high first numbers. You can see they're 811, 711. So they're high in the first number because they're high in endomorphy, and that's why they appear down in that corner. The same thing goes for people who are very high mesomorph, so that very muscular build. They'll appear at the top of the chart where that word mesomorphy is written. So you can see the number right underneath mesomorphy is 171. So that 7 being the second number there, being super high. So we know that the second number actually represents mesomorphy. And then you can see the same thing for ectomorphy as well. The third number is going to be very high when we're looking at those numbers in the bottom right hand corner of the graph. So that's how I read this chart here. And before we begin, and then at the end of this tutorial today, we're going to have a look at some examples in some athletic populations. So I've got a group of girls here in a heap of different sports, and you can see they all look a bit different, right? We know that different sports are going to favor perhaps different body types, so it's not surprising that we see differences in the body types of elite athletes. So for example, if we look at the second girl, the high jumper, very tall, very lean, you'd assume she'd be very high in ectomorphy, so perhaps she would appear down in that bottom right corner of the graph. We've got a trampoline artist. I haven't seen someone who does trampoline. Oh no, trampoline is a gymnastics. Scratch that. So trampoline, I assume that's a gymnastics event, but gymnasts generally very muscular, so they tend to appear up in that mesomorphy area of the chart. We've got boxing. Now with boxing, again, she's going to be very muscular, but she's probably also going to be quite high on the endomorphy rating as well. So generally with boxing, I guess you may not want to be super lean, because then you remove some of that protection. So adipose tissue is very good for protection, and perhaps it's advantageous for boxing in some cases. And then the triple jumper, again, she's going to be quite high in mesomorphy. So from just looking at them, we can sort of assume where they would sit. Of course, we're not going to be able to identify their 3 exact numbers without doing the measurements that we need to do, but we can have a good guess just based on our perception. And for the guys, don't worry, I've got a picture for the boys here as well. So again, we've got a high jumper at the start, would be very ectomorph, we could assume. The bodybuilder, definitely in the mesomorph category. Weightlifting, now from first sight, people tend to look at this and assume, oh, he'll be in the endomorph category. But actually, he's probably somewhere between endomorph and mesomorph, probably right in there. I'd say that he's got a really high amount of muscle mass for his body weight as well, which would put him up towards the mesomorph chart too. So maybe somewhere in between those, maybe halfway between endomorph and mesomorph for Shane. We've got triathlon, probably looking somewhere between mesomorph and ectomorph perhaps. He looks to be quite tall and slender from my view. And then a wrestler as well with the last guy. Again, I'd probably put him in the same category as the weightlifting, somewhere between meso and endo. But of course, that's just all assumptions. Now, there's something very important that I need to bring up when we're talking about somatotypes. And this topic doesn't come without heavy criticism. So if you follow, people on Instagram, there's a few, I guess you'd call them influencers that I follow who are very against this classification of body types and somatotyping. Now, the reason that people tend to tear down somatotypes and say, it's stupid, it's blah, 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 like, it doesn't matter, is because it's quite controversial. The actual origin of somatotyping is quite controversial. Now, it was a psychologist who coined this somatotyping phrase and came up with these endomorph, mesomorph, ectomorph classifications. A psychologist, right? So he actually said that based on your body type, they can predict things about your psychology and what your personality was like. And the things that they said were quite controversial. I don't think, if you tried to base someone's personality off their body type, that's going to be a quite an interesting a feat there, just because, you're muscly means that you're this or that. So I can tell you some of the things that he said. So he said for ectomorphs, so someone who's very tall and slender, he said that they were very intelligent, calm, introverted, and quite anxious. So that's putting all these people who are tall and slender into this box of being intelligent but anxious. And then he said for the mesomorphs, so for people who are muscular, they're more competitive, more extroverted. And then for the endomorphs, where perhaps we see people with some more body fat, he said that they were jolly, lazy, and selfish. So the origin of these somatotyping types is really strange. You probably wouldn't have thought that that's where they came from. Now, this is not respected anymore. So we today in this class aren't saying that if you have an endomorph body type, you're someone who's lazy and selfish. That we don't make that association anymore between body types and personality traits. But some people still do. So You might see a diet, do this diet for your body type. You might see training plans. So if you're mesomorph, your training plan looks different to someone if you're an ectomorph. Now, these I think are sales sort of tactics from, you know, people who are trying to get you to spend money. So there's definitely no diet for your body type. There's no training, like optimal training plan for your body type. But body types are real. We can put people in these somatotypes, and we can say things about their body type or their body composition from this somatotyping. It's just, if we relate that any further to psychology, to diet, to training, that's where it gets a little bit blurry. So somatotyping is real, but it's how we use it and how we interpret it that matters. Now, it's also important to say that your somatotype doesn't define you. I guess what I'm trying to say here is that you don't fit into a nice, neat box. Your somatotype can change. People lose weight, people gain muscle, people don't really get taller, but you can gain weight, you can lose weight. And by weight, I mean fat. You can gain muscle, you can lose muscle. All of these things are going to influence your somatotype. So it's important to remember that as well, that your somatotype changes across your lifespan. So if we were in class today and we were measuring our somatotypes, that doesn't mean that you are a mesomorph and that's it. It can change. It's flexible. So I guess the best representation of what I'm trying to say is if we have a look at this guy here. So this picture, if you look at this guy in this picture and you were to assume what sort of body type you'd be, you'd probably look and say he looks to be quite tall and quite slender for his height. So perhaps this person would be an ectomorph. Then if we had a look at this person here, you'd see the muscles. You'd probably assume that they were more towards that mesomorphy body type. And then finally, with this guy, you might look at him and assume, yep, that's got to be someone who would fit within the endomorphy category. Now, in actual fact, this is Christian Bale at 3 different time points in his life. So he went from all these different weights across a few different years. The craziest thing is he went from 55 kilos in 2004 to 86 kilos the next year in 2005. I do not know how that would have been possible, but you can see here that even if we're looking at the same person, that body type changes. So it's something that's very flexible. Now, in the lecture, Lee also spoke about some positives and negatives of different body types, which are also, quite interesting and sort of to be taken with a bit of a grain of salt as well. So, for example, the ectomorph, a positive was perhaps good cardiac health, whereas a negative was low upper body strength. Now, that doesn't necessarily mean all ectomorphs have good cardiovascular health and bad upper body strength. Same for endomorph, so they said it was perhaps good for flotation, but bad for low self-esteem. Now, again, that's not a guarantee that an endomorph is going to have a low self-esteem. And then the mesomorph, they said a positive was just their strength, and a negative was perhaps that exercise could become obsessive. So again, you see they're a little bit silly sometimes with the positives and negatives of these. Another negative for the mesomorph body type is actually decreased range of motion as well. So I found this video a while ago. Let's have a look at the range of motion, because sometimes you're so muscly that the muscles get in the way of being able to move properly.
Tried it.
Anyway, you guys get the point. Actually, whilst I remember, from that Christian Bale slide, Tom Hanks is another actor who's had really dramatic weight fluctuations for different roles, and he actually has diabetes now because of those really extreme weight fluctuations. So it's probably not good to be doing that. Okay, so let's get into what we're actually doing today, which is measuring our somatotypes. So to measure the somatotypes, we need to take these 10 different measurements, and then we can use the results of these measurements to actually figure out what our 3 numbers are and where we rate on those scales for each of the 3 classifications. So you guys all know how to measure height and weight. So we get our shoes off, we measure our height, and then in your lab books there's a little bit more detail about, you know, head position and things to be aware of as well. And then weight, of course, as well. We're just stepping on the scales. Now, the next thing we need to measure is skin folds. So to measure our skin folds, it's actually a measure of fat. So often you can do a whole set of skin folds and it gives you a body fat percentage. You might have seen people doing that at the gym. Perhaps your gym offers it, but if you do, I think you've got to do like quite a few. You might have to do like around 10 or so skin folds. Today we're just looking at 4, but what I'm trying to say is the skin fold measures the adipose tissue under the skin, and you can see it's done with this caliper type thing here. It's like a big tweezer that pinches your skin, and it's quite uncomfortable when it pinches your skin to measure the millimeters of adipose tissue under the skin there. So we take 4 skin fold measurements, being the tricep, the subscapular, the supraspinali, which is the tummy, and then the medial side of the calf. And those 4 skin folds collectively, they're going to help us figure out our somatotype. So taking skin folds can be quite a trial and error situation. Often we need to do a lot of practice in class. For you guys, like I said, you know, you don't have a pair of skin folds hanging around home, I'm sure. So it's not going to be a necessary part of this content. But what's actually good is that you'll learn about skin folds again in 2nd or 3rd year when you go on to do, I think, another subject. Perhaps it's in 2nd year. So it will come back up, and you will definitely have the opportunity to do this within your course. So make sure you take full advantage of that when it comes back up. So we're going to measure 4 skin folds, which give us the millimeters of adipose tissue under the skin. Then we need to measure Then we need to measure bone breadth. So bone breadth is a measure of how wide your bones are. So we take a bone breadth measurement at the humerus, which you can see in this picture here. And yes, I did get this picture off of WikiHow. There is a WikiHow article on how to take this bone breadth measurement, which is a bit random, but I guess all of those WikiHow articles are. So you take one at the humerus on the medial and lateral epicondyle, so we measure the width of that bone, and then also at the femur as well, so measuring the width of the femur bone using these, you can see that metal sort of caliper there, which presses down on the bones and gets a reading of how wide those bones are. Then we also need to take girth measurements. So probably some people have some experience measuring this one. You measure the bicep girth. So in the process of getting the somatotype, the measurement we want is actually with the arm flexed, so fully flexed. And then we also take it at the calf as well, so the widest part of the calf. So those are the 10 measurements that we need to figure out our somatotype rating. Now, once we've got them, you can see in the table in your lab book, there's quite a few. There's 3 measurement sort of columns and then an average at the end. So when we're face to face, we like to say to take 3 measurements of each, and then you can take the average just to try to account for some human measurement error there. So once we've got that filled out, what we're going to do now is go through a bit of a dummy go through some dummy results and figure out the somatotype. So let's look at taking or measuring the endomorph rating. So to get our endomorph number, we need to add up the sum of 3 skin folds: the tricep, the subscapular, and the supraspinale. The calf skin fold is actually not in this one at all. So once we add up those 3 skin fold results, we then do a little correction for height. So we need to do a little equation there to get the corrected number. And then we can see in that table on the bottom half, we find the sum of the 3 and then read across to the endomorphy rating. And in this example, this person's endomorphy rating resulted in a 4.5. So pretty simple to get the endomorphy rating. To get the mesomorphy rating, the calculations get a little bit more complicated. So we take height, we take the humerus breadth and the femur breadth, and then we need to take the bicep girth and minus the tricep skin fold, and then do the same for the calf. So take the calf girth and minus the calf skin fold. So once we have those numbers, we then find our height. So the first thing we want to do is look at the height column of that table. We circle the nearest number of height and then draw a line across the table through the other columns. So you can see how I've done that in this graph here, where I have that red line coming across. Now then we'll circle the other results. So you can see I've circled the humerus width, the femur width, and then I've circled the bicep girth minus the tricep skin fold, and then the same for the calf as well. Once you do that, you then need to count how far away those circles are from that line that you've drawn across from the height, and this will give you the sort of the deviations. So if the circle is below the line, it's a negative number. If the circle is above the line, it's a positive number, and you can see that I've written that on there as well. So for the humerus width, I was 1, 2, 3 rows below the line, so that resulted in a -3. For the femur width, I was 0, and then I did the same for the next 2 columns as well, and this gave me a total of -4 once I've added those up. Once I'm at -4, I then take that across to the next page, and then I find number 4 on that sum of deviations column. So I've circled 4 and then drawn an arrow across, and I got 0.05. Now, because the number I received in the previous page was -4, I've actually taken -0.05 as the K value. So this is all to correct for height here. And then I do that final equation down the bottom, which is the mesomorph rating. So I do the sum of the deviations divided by 8, which was 4 divided by 8. Then plus K, but because mine was a negative, I actually do minus 0.05, which was that K value, and then plus 4 to leave me with a mesomorph rating of 4.5. I hope that came across all right. Okay, and then the final one we want to do is the ectomorph calculation. So for this one, you can actually do this one at home because all you need is your height and your weight. So if this person weighed 64 kilos with a height of 164 centimeters, we do height divided by the cube root of weight to get 41. Then we find the value closest to 41 in that first column, and then I look across and I read across, and I can see the ectomorphy rating for this person is 1.5, so quite low on that ectomorphy scale. So this is actually one that you can do at home. So most people know that their height and their weight, so you can calculate this one and figure out at least what your ectomorphy number is. See if you're on the higher end of the scale or the lower end of the scale. Now, once we've done all of that, we've got our 3 ratings. So this person got 4.5, 4.5, 1.5. Now, to find that on the somatotype chart, I have circled the closest numbers on there. So there's actually 552, which would be if we round it up, and then 441, which is right next to it, which would be if we rounded those numbers down from the decimal. So you can see that this person lies pretty much smack bang in between mesomorph and endomorphy. So that is how we figure out the somatotype, and that's how we find it on the charts. All right, so then over the page, you guys have just got a couple of questions and we're going to talk through them together now. So is there a difference between the somatotypes of athletes and non-athletes? It's an interesting question, right? And really, to me, the answer is it depends. It depends on the sport, because we know that there's differences in the somatotypes between athletes. So how can we put all of those together and then compare that to normal population? Because we know that they're all different themselves. So really it depends on the sport, okay? Compared to non-athletes, a gymnast is probably going to have a different somatotype because they're very small and muscular, whereas not a lot of the population or the general population looks like that. Same thing with a high jumper. They're very tall, very slender. Not a lot of the normal population has the same body type as a high jumper. So in that case, yes, there will be differences. But what about a sport like archery? I'm not sure, this is coming out of the top of my head, so you guys correct me if I'm wrong, but I would assume that the body type of someone who's good in like an archery or a shooting sport is probably pretty similar to general population. But you can see there how with this question, it's not a clear answer. Really, it depends. We need more context. In question number 2, why do athletes in particular sports seem to have similar body types or somatotypes? Well, particular characteristics may be more advantageous in a certain sport. For example, like I said before, with gymnastics, being small and muscular is advantageous. So of course, all of the elite gymnasts are going to be small and muscular because it makes it a lot easier, or not. That's a complete generalization. Definitely not saying that gymnastics is easy, but these people with these advantageous body types are gonna have a lot more success at gymnastics than someone who's very tall. It's going to be a lot harder for someone who's taller and heavier to be able to do the same tricks. Same thing with high jump. You don't see a very short high jumper very often, do you? And that's because being short is not really advantageous. Also, it could be because of the athlete responding to the demands of training. So that's not they might have similar body types because of all of the training that they're doing in that sport. For example, a weightlifter, you're not just born muscly like a weightlifter. Perhaps that's a result of all of the training that they're doing, and that's why they're all quite high in the mesomorphy ratings. Okay. For the final part of this lab, we are looking at a comparison between 2 different sports. Now, in your lab book, it says to plot where you think an elite swimmer and a slalom canoe paddler would score. Now, I'm not going to look at the slalom canoe paddler today. I'm actually going to sub that out and compare a swimmer to a high jumper. So if you want, you can just cross out the canoe paddler and write high jumper, and we can talk through this comparison today. So in terms of where they'd fit on the somatotype chart, first of all, let's talk about their physical characteristics, right? So we'll get to the chart in a second. Let's move down now. What are some of the similarities, differences between them? What's unique to these different sports people? So we know with the swimmers, they're very tall. They're quite lean. Some not super lean, but they're quite lean. They do have some fat. They have a long arm span, so they've got those really super long arms. They've got a very long torso, a long trunk, and they tend to have this V-shaped body type, so really broad shoulders and a more narrow waist, narrow hips or narrow pelvis. They're also very flexible. They have big hands and big feet, which help with the propulsion through the water. Whereas with the high jumper, they tend to have a very short torsos and long legs. They're very lean, so they want to be very light to propel themselves through the air. Another interesting thing about high jumpers, I only found this out recently when I was looking up what are some of the physical characteristics of a high jumper. Apparently they have quite flat bottoms or quite flat gluteus maximus, and that's because when they get over the bar, even that, you know, a couple centimeters of booty out the back there might hit the bar off. So perhaps being an Olympic champion comes at the expense of the gluteus maximus. But yeah, that's quite an interesting physical characteristic I never really considered before. Okay, in terms of some other physical sort of capacity measures that might differentiate between them, definitely things like lung capacity. So the swimmer is going to have very, very good lung capacity. The high jumper perhaps not so much. And then of course just the proportions between them. So, you know, they're both quite tall and quite lean, but the swimmer's got this longer torso, whereas the high jumpers tend to have the shorter torso and the longer legs. So then if we have a look at the somatotype chart now, this is where I put them. Put the swimmer up here near the mesomorphy, perhaps crossing a little bit into endo, just to allow for those ones that aren't super lean. And then the high jumper definitely down the ectomorphy corner, but sort of towards mesomorphy as well, because they are very muscular too, but the leanness definitely, or the ectomorphy definitely beats out the mesomorphy when it comes to the high jumper. So this is something that this is somewhere I'd be looking at when we're talking about these two different sports. All right, guys, so that is somatotyping. Like I said, unfortunately, we had to do what we can with this tutorial. I hope you still found it interesting, and I hope to see you in the Zoom sessions this week.